has to done using data. Data is required. Data is required in order to operation. So that means data is required from an operation which will not be generated internally. A empty unit cannot be generate the data internally. So it requires something to generate the data. So here the user through this input unit will provide the data to the microprocessor unit on which this operation is to be performed. Which this operation is to be performed. Again the microprocessor the data will process the data. It will process the data and it will generate some result. So it will generate some result. So this result will be by the user again. So the user will take the result again by using the output devices. So result will be received by the user by using this output units. So let's say a user has given some data using keyboard. Okay, so using keyboard, user has provided some data to this memory unit, sorry, microprocessor unit. So this microprocessor unit has to keep this data in the memory. Okay, so that means it has to remember the data whatever the user provided to it. So in order to remember the data, it will store the data in some external unit called as memory unit. So in order to perform an operation, data from this unit has to be processor. Okay, so the microprocessor has to collect the data from this memory unit in order to run this operation. So if the data memory unit only the data is stored in the memory, so then only it wants to read the data from memory unit. Okay, so whenever the MPU wants to perform an operation, it will recall the data from this memory unit and it will again process on the data and it will generate some result. So the result so this output unit the result will be added to the user. So this is how the process of processing the data will be done in this microprocessor. So okay, so the operation will be performed by this microprocessor in the process which I have explained. So in order to make it possible, we need to establish some connections between this input unit, output unit and memory unit. So that process of establishing the connections is called as interfacing. So this is what we have discussed in the last class and we have discussed something called input port and output port. So input and output port. So we have discussed about this concept. Okay, port. What is it? So input something which to the input data provided by the user. So if the user wants to transfer the data to the microprocessor, then input is used to keep the data from input device. So whatever device we are using here, it is keep. So whatever the input device we are using in order to read the data from this input unit. So input is used. What is the input port we have used? Buffers. Okay. Stated buffer we have considered it as a input unit. So the buffer will be activated on enable buffer. So whenever buffer activated, so whatever the data that is present in the input will be received by this buffer circuit and again transfer the data of processor. Similarly, at the unit, so as output, provide the data, the processor provides the data called as result. Result is latch. So the circuit we clock it to activate latch. Here the circuit and the latch is called as interfaces. This is called as interface devices. The buffer circuit and that called as interface.
మ్యామ్ వాయిస్ బ్రేక్ అయిపోతుంది మ్యామ్.
వాయిస్ బ్రేక్ అవుతుంది. So now is it వినిపిస్తుందా నాన్న?
ఎస్ మ్యామ్.
Yes, madam.
So here we discussed. So we thing called your first concept of unit 3 is semiconductor memory. Semiconductor memory interface. So this is your first concept. So let's see. You all know about interfacing. So you all know about interfacing. I don't want to repeat it again. So this process of connecting some devices to the microprocessor. So here we are. Your first concept is semiconductor memory. What is meant by semiconductor memory? So let's talk about memory first. So what is meant by memory? So what is meant by memory? Nana, memory.
Stores from the data.
Yeah, so memory is something which is used to store the data. So we will work on the microprocessor, or the user will work on some data. So the user wants the microprocessor to operate on some data. So the device which is used to store this data. So the device which is used to store this data is called as memory. So the device or the location or the space. So area or space. So which is used to the device or location or space which is used to store this data is called as memory. So memory is nothing but it's a location or some memory space, some space which is used to store this data. So the user will always wants the microprocessor to operate on some data. So it has to perform the operations on a particular valid data. So that data should be stored in some location. So that location or the area is called as memory. So we have different types of memories, right? So memories are categorized into various types. So we have various types of memories. So different types of memories we are having. So out of these different types, there are two basic kinds of memories. Okay. So we have you can come up with a lot of varieties of memory, but out of this we will consider two memories as basic memories. So one is RAM and another one is ROM. So first one is random access memory, RAM, and next one is read only memory, ROM. So these are the two kinds of memories which are considered as basic memories. Okay, so these two are called as basic memories which are used to store the data. So we have different types of memories, out of which these two are the basic types. So what are the various categories of memory we are having? We are having SRAM, DRAM, SDRAM, so SD. So next you are having some EROM, EPROM, so EAROM, EPROM, EEPROM, flash memory. So you have all these varieties of memories. So you have different varieties of memory, a variety of different memories are available, different memory technologies are available based on the applications. Okay, based on the applications the user want to perform, based on those applications a large varieties of memories are available. So but basically these all will be categorized into two basic types of memories. So these are all semiconductor memories. So we are categorized these two under two basic, these are all under two basic categories of memory. So here if you can see SRAM, DRAM, SDRAM, ROM, EPROM, EEPROM. So that means everything will be, every memory will be belongs to either random access memory or read-only memory. So a variety of different memories are available, but out of which we have two basic memories, two basic types of memories. So these two are called as semiconductor memories. So semiconductor memory is used in any electronics assembly programming by a computer. Okay, so whenever we are using whenever we are performing a computer processing technology, whenever we are performing some operations with this computer processing technology, so in any of the type of technologies, in any of the type of operations, so this RAM and ROM, semiconductor memories, will be used. Okay, semiconductor memory is the essential component for the computer. Okay, so it is the essential part of the computer. So if we are assembling with respect to some electronics, so if we are discussing about some electronics like PCB, etc., etc., so then also we have to use these semiconductor memories. So in addition to this memory cards, okay, so in addition to this memory, we will use something called memory cards, which is used to store the data. So we have two types of memories, one is RAM and one is ROM. These two will fall under semiconductor memories. So you all know about RAM and ROM, right? So what is RAM? It is random access memory. Random access memory, which is volatile. So it is volatile type of memory. So it is a random access memory. It is a volatile type. So that means whenever we are talking about this random access memory, so whatever the data that we store in this random access memory will be erasable. So whatever the data we will store in this random access memory can be erasable. So that means RAM is something which can be erasable. So it's a type of memory where we can erase the data. So where we can able to erase data. So the data in the RAM can be erasable. So it is a semiconductor memory technology which is used for reading and writing of data in any format. So it is used to read and write the data in any format. So in any format here means the format required by the microprocessor. So in what format the microprocessor requires the data, so that format, in that format only we can store the data in this RAM. So if the microprocessor is operating on strings, so the strings are stored in this RAM. So if the microprocessor is operating on numbers, the numbers are stored in this RAM. So if the microprocessor wants the data in type of ASCII, so combination of numbers, variables, etc. and all, so that will be stored directly. So it can read and write the data in any format. So that means in any format here represents the format in which the microprocessor wants. How the microprocessor wants the data to get an operation to be done. So that type of data will be stored in RAM. Okay. So whatever the data wanted by the microprocessor, that data will be stored in RAM as is. How the data is available, it can be able to store it. So no modifications are required on data when we want to store it in RAM. So since it is volatile memory, so it is a volatile memory, so that means it will store the data only for a particular time period. So that means whenever we turn off the computer, the data stored in the RAM will get erased. So next thing you are having is ROM. So ROM is nothing but read only memory. So read-only memory. This memory is non-volatile. Non-volatile. So this is a non-volatile memory. So ROM can be designed in such a way that whatever the data we are storing in this read-only memory will be. So it is a permanent memory. Non-volatile nature is nothing but permanent type of. It is a permanent. To be erased electrically in the following types. So other some advantage, this ROM can be also erased as volatile. So be erased electrically. So that means electrically erasable, programmable, read-only memory. So first the ROM is available in such a way that it is non-volatile and it cannot be programmable. So whatever the size or whatever the uh, available for ఎన్ని రోజులన్నా కానీ అంత అవైలబిలిటీతో సిస్టమ్ డిజైన్ చేస్తే అంత రోమ్ అవైలబుల్ గా ఉండేది. బట్ హియర్ వీఆర్ గెటింగ్ అన్ అడ్వాన్స్మెంట్ ఇన్ రోమ్ విచ్ ఇస్ కాల్డ్ as electrically erasable programmable read only. We can alter the status of ROM even after manufacturing. Okay, so which is called as EEPROM. So it is electrically erasable programmable read only memory. So you have categories of RAM, SRAM, DRAM, SDRAM, static RAM, dynamic RAM, and the combination of static dynamic RAM. So next EROM, memory. So next electrically alterable read-only memory, electrically programmable read-only, electrically erasable programmable read-only. So these are all different types. Is categorized under RAM and ROM types. So this both so you have different types of this. You have these all different types are categorized under two basic types, RAM and ROM, and you have all the properties of RAM and ROM memories. So next you have something called interfacing of this semiconductor memory. So semiconductor memory. So you know semiconductor memory now, and you know interfacing now. Now you have to discover this two in a page. So means we have discussed this combined so in semiconductor memory. So you have here the concept of interfacing now. And hello. So you are clear with
మ్యామ్ వాయిస్ బ్రేక్ అయిపోతుంది మ్యామ్.
అసలు hello, am I audible now?
ఎస్ మ్యామ్.
Hello. Yes, sir. So you can interfacing అర్థమైంది కదా? ఇంటర్ఫేసింగ్ అంటే అర్థమైందా?
ఎస్ మ్యామ్.
ఏంటంటే అర్థమైందా? Hello. Can you able to hear me now? So you got about interfacing, right?
ఎస్ మ్యామ్.
So you got about something called memory, semiconductor memories, right? నాన్న ఇప్పుడు వినిపిస్తుందా వాయిస్? ఆమె క్లియర్ నౌ?
Yes, ma'am.
హలో. ఓకే. Now let's discuss about something called memory interfacing. So screen visibility okay na?
Okay, ma'am.
So memory interfacing. So let's discuss about the combination of interfacing with semiconductor memory. So I have explained about interfacing concepts, so which you are very clear with. So you have understand the concept of interfacing, right? So this is what interfacing is. So what is the requirement of interfacing and why we are going for interfacing? Since the microprocessor will not contain everything on chip, so we have to connect external devices and hence we are going for a concept interface. So interfacing is thing connect devices with the processor. So next you have second memory. So you have memory is not it's a device or to the process. Okay, so it is to that about okay, clear about semiconductor this let's discuss about interfacing. So memory interfacing. So interfacing is the integral part of microcomputer. Okay, so it's the part of microcomputer. Why I'm doing it as an part of computer means without memory facing we will not do anything. We will to perform any operation microprocessor unit. So if you consider a microprocessor unit, so whatever components that are presented internal to the microprocessor unit cannot be capable of performing without the data. Providing data, the microprocessor unit can perform the operation. Okay, so when it age can do functions that we internally fixed component to this microprocessor. Since I do it, this microprocessor unit is capable of performing the operations. However, so it cannot perform the operations without providing the data. So it cannot perform any operations without providing this data. So data is mainly required in order to produce a result for a particular operations by this microprocessor unit. So this data, we made this data to get stored under a memory unit. So we made this data. The user made this data to store under a memory unit. So whatever the data the programmer is presenting to the microprocessor unit, the entire data will be stored in microprocessor unit. So he will give a lot of instructions to this microprocessor unit. So the instructions will be again stored in this memory unit. So he will write some codes in order to execute a task. So that codes also will be again stored in this memory unit. So memory, without memory, so we cannot perform any operation even in the presence of ALU and a microprocessor unit. So that is the reason it is the integral part of microcomputer. So memory interfacing is the integral part of microcomputer system. Okay. So microprocessor system and microcomputer system. So I have said you that we have two types of memories. One is RAM and another one is ROM. So we have two categories of type of memories that fall under semiconductor memory. So one is RAM and another one is ROM. So while executing a particular task, necessary to access the data. Okay, so if the microprocessor user wants to perform a task, user will write the commands to execute this task. Whenever we want the microprocessor to perform a task, so the microprocessor to instructions. So it has instructions from this memory unit. Here the instructions may be pure instructions or some commands or some data. So anything. So the instructions may be anything. So it may be a pure instruction. It may be some commands. It may be some data. It may be some codes, etc. So whatever might be the thing, whatever might be the instructions, it will be accessed the microprocessor. So the microprocessor has to get the instructions, data, commands or codes from the memory unit only. Okay. So since everything will be stored in the memory unit, it will get interfaced with this microprocessor unit, and this memory interfacing is the integral part of microcomputer. So it is the major part of the microcomputer. So interfacing a microprocessor with a memory will be a integral part. So whatever the code, whatever the command, whatever the instruction made by the user, so given by the user, will be stored in this memory unit only. So whenever the microprocessor unit want to perform a task, it has to get the data or command or the code from this memory unit. Clear?
Yes,
Ardhamainda? Okay. So whenever it wants to perform a task, so then this microprocessor unit will initiate the necessary signals. So what are the signals? Read and write. So read, write are the commands. So these are the signals which are initiated by this microprocessor unit in order to initiate this task. Okay. So it will make these signals active accordingly. So if you want to get the data from this memory unit, it will activate the read signal. Okay. So that means whatever the data stored in the memory, that will be accepted by this microprocessor. Okay. So it will initiate a read command. So on activating this read command, the memory unit contains some data. So that data will be read by this microprocessor unit. So that means it will get the information from the memory unit. So read is nothing but from memory unit to microprocessor unit. Okay. So from MU, memory unit, to MP, microprocessor unit. So it will get the information from this memory unit to this microprocessor unit under this read command. So write command means after data has been processed. So it will get some data from this memory unit. It will work on the data and it will generate some result. So that result, it again has to store in this memory unit. So the result will be again stored in the memory unit. So on activating this write command, so whenever the microprocessor activates this write command, so whatever the result that the microprocessor creates will be again stored in the memory. So that means it will be written into this memory unit. So first it will read the data and again it will write the data. So that means reading of data is nothing but initiating the task. So after completing the task, it will generate some result and the result will be stored in the memory unit again, which is nothing but writing of data. So in order to perform a task, in order to accomplish a task, the microprocessor unit will initiate the commands. We will initiate these signals, either read or write is to be performed by this unit. So how this communication, so reading and writing are the signals generated by this unit. How these two will communicate? So if we want to know how the unit gets communicate, you first have to know about this memory device. So whenever we are connecting some memory device to this microprocessor unit, so the both will get synchronized. That means whatever the commands the microprocessor initiates, those commands will be received by this memory unit. How? So let's talk about this memory unit first. So this is how a memory device looks like. So let's say this is a memory device. So this memory device will now consist of some address lines. Okay. Let's say A0 to AN. So it will consist of some address lines. So address and data lines will be present in this microprocessor unit, and address lines will be present in this memory device. So the communication between the transfer of data, so the receiving and transferring of data will be done by this address data lines and these address lines. So the address data lines of the microprocessor unit will be connected to the address lines of this memory device, so that they will exchange the data. Okay. So next you have some input output lines, IO1 to ION. So these are input output lines. So next you have something called chip select. So this is CS bar chip select. So next you have read bar, so which initiates read command. So next you have write bar. So next you have some memory locations. Okay. So this is how a memory device will be looks like. Okay. So this is how a memory device will be. So these are the things which are present in this memory devices. So all memory devices have address lines, input lines, chip select, read, write, and some memory locations. Okay. So these are all will be accomplished with this memory device. So with by making this microprocessor unit and this memory unit to get synchronized. So that means whatever the command the microprocessor initiates, this memory device will be able to receive that command. So then they will get synchronized, and whatever the transformation of data will takes place will be entirely taken from this address lines, and the output will be displayed through this input output lines. Okay. So all the memory devices have this address and input lines that selects the location of the memory of the device. So by using these lines only we will select the memory device. So we will select the memory location within this memory device. So by using this address lines and input lines. So address lines and input lines. So input output lines, not input output lines. So input lines. So these are input output lines. By using address lines and input lines, we will select the memory location within the memory device. So this memory device have a number of memory locations, out of which one location will be selected by using this address and input lines. So these address lines are labeled as A0, A1 and so on AN. So that means A0, A1, A2, A3 up to AN. So based on the capacity of this memory, so this memory device capacity, so these address lines will be given. Okay. So if the memory capacity is 1K, so if the memory capacity of this memory device is 1K, so then we will need 10 address lines. So we require 10 address lines in order to communicate with this MPU unit. So if the memory device, the value of this memory device is, so if the capacity of this memory device is 1K, so then we require 10 address lines, A0 to 9. So 10 address lines in order to establish the access between this microprocessor unit and this memory. So if it is 1 MB, we require 20 address. So 20. So that means this memory device, so the address lines will be provided to this memory device. Okay. So the memory devices may have separate input output lines, or they may be multiplexed. So some memory devices will have input lines I1, I2, I3 and so on IN, and output lines O1, O2, O3 and so on ON. So input and output lines separately, or some may have IO1, IO2 and so on ION. So likewise multiplexed lines. So based on the type of memory device, some memory devices will have a individual input output lines, and some memory devices will have bidirectional input output lines, which means multiplexed input output lines. So some memory devices will have separate lines for input, separate lines for output, and some may have bidirectional. So that means input lines and output lines, representation of input and output lines. So how input lines will be represented likewise, how output lines will be represented likewise. So some will have likewise. So like this, some will have a bidirectional input output lines. Okay. So we have address lines. So based on the memory capacity, so based on the device capacity, so these address lines will be provided to that particular device. So 1K memory capacity aithe, so you will have this address lines as 10 address lines. So you will have 10 address lines. So if you have 1K memory for this memory device, you will have 10, you will get 10 address lines. So if it is 1 MB, you will have 20 address lines. So A0 to A19, that is 20 address lines. So based on the capacity, these address lines will be provided to this memory device. So next you have input output lines. So input means which takes the data, output means which provides the data. So these input lines and output lines will be depend upon this type of memory device. So some memory devices will have separate input and output lines, and some devices have a bidirectional input output. Using these lines, the data can be transferred in either direction. So we can give the data into the memory. So that means by using input lines, we can store the data in the memory, or by using output lines, we can take out the data from the memory. Okay. So we can use these lines to transfer the data in either direction. So we can take out the data. Select. So this chip select is also called chip enable. Okay, chip enable. So chip select and chip enable are same. Sometimes you will come across CS, and sometimes you will come across CE. CE is chip enable and CS is chip select. Both are same. So how this chip select is used? So whenever this chip select is on logic 0. So whenever this chip select is on logic 0, so only this memory device will perform read and write operations. So the read and write operations will be only this memory device. Other device will be accessed by this memory device. Okay, so it has independent read and write operations. Has own rights to perform the read-write operations. Once CS bar is under logic 0, so this memory device performs the read and write operation. So that means the microprocessor unit accesses the data from this memory unit, and it will perform the particular task. Or else if the chip select bar is on logic 1, so that means it is on logic 1, so then memory device will be disabled. Okay, so then memory device will be disabled. So if CS bar is on logic 1, so the memory device connected to this MPU unit will be disabled. So that means whatever the data that is present in this MPU unit, so MPU consists of some registers, right? Internally there are some registers. So those registers are also capable of storing the data. So using the data, it has to perform the task. So no external memory is connected to this MPU unit. Okay. So under chip select 0, even though it got interfaced with this MPU unit, so this memory device and this microprocessor unit are got interfaced. Under this chip select is equals to 1. So under logic 1 of this chip select bar, so no memory device will be enabled. So this memory device will not have an access to work with this MPU unit instructions. Okay, so on this MPU unit instructions, this memory device will not change its data, it will not provide the data, it will not take the data. So this memory will got disabled even though it is connected physically, it will not able to access the data. So this is what this chip select pin is for. So next you have read and write pins. You all know about this read and write pins. So whenever this read bar is equals to 0, read operation will be performed. Whenever this write bar is equals to 0, write operation will be performed. Okay, so whatever the operation performed by this memory unit, CS bar should be in the active state. So CS bar is active when it is under logic 0. CS bar. So CS bar is active when it is under logic 0. That means CS bar is equals to 0, CS is equals to 1. So that means chip select will be enabled under logic 0. So active state indicates that CS bar is 0. Okay. So any operation will be performed by this memory device only when this chip select is active state, is in active state. That means it should be at logic 0. Clear?
Yes, ma'am.
Clear. Okay, so this is how the memory interfacing is done. So this memory device will be interfaced with this memory microprocessor unit. So this will get connected with this microprocessor unit. So this microprocessor unit has some address data lines which are connected to this address lines of this memory device in order to transfer the data. Okay, so input output lines will will allow this memory device to store the data or to send the data. So, CS bar, so it is chip select which is used to make the device enable or disable with this microprocessor unit, and read and write are the operations which are performed by call of MPU. So whenever this initiates this read or write signals, microprocessor unit initiates this read or write command, so then this memory unit will provides the data to the microprocessor unit. So this is how the interfacing is done. So this is the memory device unit, and you all know the microprocessor is a 40 pin device. Okay, so it is a 40 pin IC. So you have 20 address lines and 16 data lines which are multiplexed up to 16 address data lines, and remaining 4 only address lines. So these will be connected with these lines, and on chip select command activation, the transferring of data will be done and the operations will be performed. So let's see how this memory interfacing will be done using RAMs and ROMs. So you are asked to interface the memory unit. So this is your memory unit. So this memory unit should be, so memory interfacing unit will be a RAM. So we have to consider a RAM, and we have to interface it with 8086. So next you have to consider any type of ROM, and you have to interface it with 8086. How this interfacing of RAM with 8086 and ROM with 8086 will be there, let's see in the next class. So is it clear for today? Class
Yes, ma'am.
అర్థమైందా? Okay, so I'm terminating the class here. ఎందుకు మనకి కాన్సెప్ట్ మధ్యలో ఉండిపోతుంది, మళ్ళీ నెక్స్ట్ క్లాస్ లో అది ఇచ్చేది. సో ఇన్ ద నెక్స్ట్ క్లాస్ ఫ్రెష్ వర్క్ చేసుకుందాము. సో దట్స్ ఆల్ ఫర్ టుడే. థ్యాంక్ యూ.